Nothing major ever just happens to a Ram overnight. Real failures usually start as tiny changes most owners dismiss: a different sound, a slight delay, a smell that wasn't there before. Those early signals are mechanical clues, not coincidences. Today, we're going through the small signs that show up first, the ones that quietly turn into expensive repairs if you keep ignoring them. Make sure you listen carefully to all of them, because they could save your truck. Let's begin. Number 9. Slight coolant smell after driving. You park the truck after a normal drive and catch a faint sweet smell near the front end. No puddles under the vehicle. Temperature gauge stays normal. Most owners ignore it. That smell is often early coolant seepage, not a catastrophic leak. On Ram trucks equipped with the 5.7L Hemi or 3.6L Pentastar, the cooling system operates under roughly 16-18 psi of pressure when fully warm. Even a very small breach at a hose clamp, water pump seal, or radiator seam can allow vaporized coolant to escape without leaving visible drops. Water pump seals are a common early source. After 70,000, 100,000 miles, the internal bearing and seal can begin to weep under pressure. It may not drip enough to leave a puddle. Instead, coolant evaporates on hot engine surfaces, creating that sweet odor. Plastic radiator end tanks are another failure point. Over thousands of heat cycles, the crimped seals between aluminum core and plastic tank can develop microgaps. At highway operating temperature, vapor escapes. When cooled, pressure drops and no fluid is visible. Small coolant loss over time matters because coolant level affects heat transfer efficiency. Even slightly reduced coolant volume increases thermal stress, especially under towing or hot climate conditions. Repeated high-temperature exposure accelerates gasket aging and thermostat wear. Ignoring early seepage means that when failure finally becomes visible, coolant loss can happen rapidly. Overheating a modern aluminum engine, even once, risks head gasket compromise. Cooling system issues rarely begin as dramatic failures. They begin as pressure retention loss. If you consistently notice coolant odor after driving, inspect. Water pump area for dried residue. Hose connections for crusted deposits. Radiator seams for white or pink film. Coolant reservoir level over multiple days. A cooling system that smells without dripping is already signaling that sealing integrity is weakening. That signal usually comes tens of thousands of miles before an actual overheating event, if you choose to notice it. Number 8. Slight vibration between 40-60 miles per hour. If your Ram feels completely fine at low speeds and under hard acceleration, but develops a faint vibration between roughly 40 and 60 miles per hour, that is not something to brush off, especially if it disappears once you accelerate past that range. On 2013-2022 Ram 1500 models with the 8GP transmission, one common early cause is torque converter clutch instability. Around that speed range, the converter begins locking under light throttle to improve efficiency. If transmission fluid has started degrading, often after 60,000, 80,000 miles without service, the clutch doesn't apply smoothly. The result is a subtle shudder that feels like light road texture. Many drivers assume it's tire balance. They rebalance wheels, sometimes twice, and the vibration remains. Another possibility in that speed band is driveshaft imbalance or early U-joint wear. Ram 1500 trucks use relatively long drive shafts, especially in crew cab configurations. Even minor imbalance or slight U-joint play creates vibration at highway cruising speeds before becoming obvious at higher speeds. In lifted or leveled trucks, driveshaft operating angles change slightly. Over time, that increases wear on universal joints and carrier bearings. Early wear doesn't create loud noise, just a faint harmonic vibration. If you feel the vibration in the seat more than the steering wheel, suspect driveline rather than front wheel balance. Steering wheel shake typically points to front-end issues. Seat or floor vibration often points rearward. This matters because vibration under light load is often the first mechanical symptom before larger repair. Torque converter damage that begins as light shudder can turn into full clutch glazing if ignored for tens of thousands of miles. Worn U-joints eventually develop clunk under acceleration. The key is that this vibration appears early, quietly, and in a very specific speed range. That precision tells you it's mechanical resonance, not random road feel. Ignoring it allows wear to progress from subtle imbalance to actual component failure. Number 7. Steering that feels loose or less precise. You're on the highway doing 70 miles per hour. The road is straight, and yet you're making small steering corrections every few seconds. The truck isn't pulling hard left or right, it just doesn't feel planted anymore. That subtle change is usually mechanical, not psychological. As front-end components wear, steering precision degrades gradually. Outer tie rod ends are common wear points once mileage climbs past the mid-range of ownership. Even minimal internal looseness translates into measurable toe variation under load. At highway speed, that variation becomes small lane drift. Ball joints contribute as well. When lower ball joints begin to develop vertical play, the wheel no longer stays perfectly aligned under braking or acceleration. It shifts slightly. The steering wheel feels less connected. Control arm bushings soften with age and heat cycles. Rubber loses rigidity over time. Under load, especially braking from 60+ mph, that movement slightly alters alignment angles. Drivers experience this as vague tracking or mild instability in crosswinds. Trucks running larger aftermarket tires accelerate this wear. Increased rotational mass and leverage place more strain on tie rods and ball joints compared to stock wheel setups. One useful check: look at your front tires. If inner tread wear appears slightly heavier than outer tread, especially paired with increased steering correction on the highway, toe movement under load is likely occurring. Electric power steering masks some of this. Assist smooths over feedback that older hydraulic systems would have transmitted directly. That's why the change feels subtle instead of dramatic. The key is progression. It does not go from tight to dangerous overnight. It slowly loses precision. If highway correction effort has increased compared to how the truck drove 20,000 miles ago, components are likely developing play. Catching individual pieces early prevents multiple front-end parts wearing together. Steering rarely announces failure loudly at first. It whispers through feel long before it makes noise. Number 6. Brake pedal pulsing very slightly. If you feel a light rhythmic pulse in the brake pedal while slowing from 40–60 miles per hour, that is almost always early rotor thickness variation, not ABS activation. On full-size trucks like a Ram 1500, front brake rotors typically measure around 13 inches in diameter depending on trim. They handle significant thermal load, especially in vehicles weighing 5,000 to 6,000 pounds. During moderate braking from highway speed, rotor surface temperatures can exceed 400–500 degrees Fahrenheit. Uneven heat distribution at those temperatures causes material transfer and localized thickness change measured in thousandths of an inch. It doesn't take much. A rotor thickness variation of 0.001–0.002 inches is enough to create pedal pulsation. Two common causes. First, improper lug nut torque. If lug nuts are tightened unevenly or over-torqued with an impact gun beyond spec, typically around 130 lb-ft on many Ram 1500 models, the rotor does not sit perfectly flush against the hub. Under repeated heat cycles, that uneven seating creates distortion patterns. Second, seized or partially restricted caliper slide pins. When calipers do not move freely, one pad applies more pressure than the other. That uneven clamping force causes hot spotting on the rotor surface. Over time, that becomes permanent thickness variation. The early sign is light pulsation at moderate speed. At this stage, stopping distance is usually unaffected. If ignored, vibration worsens, steering wheel shake develops under heavier braking, and pads wear unevenly. By the time vibration becomes noticeable at 65–70 miles per hour braking, rotors are typically beyond resurfacing tolerance and require replacement. In many cases, both pads and rotors must be replaced to prevent recurrence. Front brake service on a Ram 1500 can range significantly depending on components used. Waiting allows heat damage to compound, especially if hub surfaces are not cleaned during installation. Brake pulsation does not start severe, it begins microscopic. When you feel it early, the rotor has already begun changing shape under load. Number 5. Slight delay. When shifting into drive or reverse, you start the truck, press the brake, shift into drive, and there's a small pause. Maybe half a second, maybe one full second. Then it engages. No bang, no harsh slam. Just a delay that wasn't there before. That is not normal aging. In 8-speed automatic Rams, especially 8 HP-equipped trucks, engagement into drive or reverse depends on hydraulic pressure building quickly inside the transmission. When fluid is healthy and internal seals are tight, engagement is nearly immediate, typically under half a second. A growing delay usually points to one of 3 early conditions. First, fluid degradation. Automatic transmission fluid breaks down with heat. After 60,000–80,000 miles, especially in trucks used for towing or city driving, viscosity changes and clutch apply time increases. Second, internal clutch pack wear. Engagement requires hydraulic pressure to compress clutch plates. If there's early wear or glazing, more pressure time is needed before full lockup. Third, valve body or mechatronic adaptation issues. The transmission control system constantly adapts to wear. If adaptation values are compensating heavily, you may begin feeling slight hesitation before actual failure occurs. This is where most owners wait too long. A 1-second delay doesn't feel urgent. But if engagement time continues increasing, clutch material is wearing. Eventually, delayed engagement becomes harsh engagement. Harsh engagement becomes internal damage. Another indicator: does it happen more after the truck has been sitting overnight? Cold fluid plus marginal seal wear often shows symptoms first thing in the morning. This symptom does not appear suddenly, it progresses. A transmission that used to engage instantly but now hesitates is telling you hydraulic efficiency is declining, and hydraulic efficiency declining is the earliest measurable stage of automatic transmission wear. Ignoring it doesn't stop wear, it allows it to accumulate quietly until engagement quality becomes impossible to ignore. Number 4. Clicking noise when turning at low speed. You're pulling into a parking lot. Steering wheel turned almost full lock, windows down. You hear a light clicking or popping sound from one front corner. It doesn't happen at highway speed. It doesn't happen driving straight. Only when turning slowly. That is rarely nothing. On independent front suspension Ram trucks, low-speed turning noises often point toward outer CV axle joints beginning to wear. The outer CV joint handles the highest angle when the wheel is turned sharply. Over time, especially past 80,000 miles or after running leveled suspension, the joint begins to develop internal clearance. The early sign is rhythmic clicking under load during tight turns. CV boots can also crack microscopically without obvious grease spray. Once even a small amount of grease escapes, contamination begins. Dirt entering the joint accelerates internal wear. Another possibility at low speed is sway bar end link play. End links use small ball joints that develop looseness over time. Under tight turns, especially entering driveways at slight angles, they can create light popping sounds. Ball joints are another candidate. Early lower ball joint wear can create single clicking noises as steering load shifts weight across the joint. Why this matters? A CV joint that begins clicking will not heal. Once internal grooves wear, material continues degrading. Eventually, the clicking becomes louder, and under acceleration in turns you may feel slight vibration. Replacing a single axle is manageable. Ignoring it long enough risks joint failure under load, especially if torque demand is high. If the clicking is repeatable at slow speed with steering angle, it is mechanical. It is not road noise. Low-speed turning noises are rarely catastrophic at first, but they are specific. And specific noises tied to steering angle point directly to rotating front-end components under stress. Catching a CV or joint early keeps the repair contained. Waiting usually means more than one component is worn by the time the noise becomes obvious. Number 3. Oil level slowly dropping between changes. You change your oil at 5,000, 7,000 miles. Everything looks normal. Then around 3,000 miles into the interval, you check the dipstick and it's half a quart low. No puddles, no smoke, no warning lights. That is not something to ignore. Engines like the 5.7L Hemi and 3.6L Pentastar can begin consuming small amounts of oil as mileage increases, often somewhere after 60,000, 80,000 miles depending on driving style and maintenance history. The cause isn't dramatic failure, it's gradual internal wear. Piston rings lose tension over time. Valve stem seals harden from repeated heat cycles. PCV systems begin flowing slightly differently. None of those immediately trigger a dash warning. Here's the part most owners miss. Modern engines rely heavily on consistent oil volume for hydraulic components. Variable valve timing systems and hydraulic lifters depend on stable pressure. Running even 1 quart low reduces total oil capacity by roughly 15–20% in many light-duty engines. Lower oil volume increases oil temperature under load. Hotter oil thins faster. Thinner oil reduces film strength. That accelerates wear on cam phasers, lifters, and timing chain guides. Small oil consumption becomes a larger problem when owners also extend oil change intervals. If the engine is already losing oil slowly and you're stretching intervals to 7,500, 10,000 miles, additive breakdown compounds with lower volume. By the time oil consumption becomes visible as smoke, internal wear has progressed significantly. The early sign is simple: oil level trending downward between normal intervals. Tracking how much oil you add matters. Half a quart over 5,000 miles is very different from a quart every 2,000 miles. The trend tells you more than the warning light ever will. Oil consumption does not jump from zero to catastrophic. It starts small. And small changes in lubrication stability affect long-term engine durability more than most drivers realize. Number 2. Transmission downshifts that feel slightly harsher than before. At first, it only happens occasionally. You're slowing down toward a traffic light, maybe around 25-30 miles per hour, and just before coming to a stop, the truck makes a slightly firmer downshift. Not a slam, not a violent jerk, just a sharper engagement than it used to have. Most owners assume it's normal behavior of an 8-speed transmission. It isn't random. Modern Ram trucks with the ZF-based 8-speed automatic rely heavily on adaptive learning. The transmission control module constantly adjusts clutch pressures and shift timing based on wear, throttle input, and fluid condition. When fluid begins degrading or clutch packs start wearing unevenly, adaptation values increase to compensate. That compensation is what you feel. Harsh 3-2 or 2-1 downshifts at low speed are often early signs of clutch pressure irregularities or valve body adaptation strain. It does not mean the transmission is about to fail. It does mean internal wear has reached a measurable point. Another contributing factor is fluid aging. Transmission fluid viscosity changes with heat cycles. Trucks used frequently in stop-and-go city traffic see significantly more shift cycles than highway-driven trucks. More cycles mean faster clutch wear per mile. By the time harsh downshifts become frequent, clutch surfaces may already show accelerated glazing. At that stage, adaptation alone cannot smooth the shift. Owners often wait until the shift becomes obvious on every stop. That's when internal wear has compounded across multiple clutch packs. The early sign is pattern-specific harshness at low speeds. If the transmission used to feel seamless and now occasionally feels mechanical, that change matters. A transmission does not alter its shift character without a reason. Small irregularities in downshift smoothness are data. Ignoring them allows hydraulic wear and clutch adaptation to move from compensation stage into mechanical damage stage. The shift you barely notice today is often the first measurable indicator of long-term transmission stress. Number 1. Engine getting slightly louder under load. You're merging onto the highway and you notice something subtle. The engine sounds a little harsher than it used to when accelerating. Not knocking, not misfiring, just louder, slightly more metallic, slightly less smooth. That change is usually gradual, which is why it gets ignored. On engines like the 5.7L Hemi, increased combustion noise under load can be linked to knock correction activity. Modern ECUs constantly adjust ignition timing when they detect minor detonation events. When carbon buildup increases inside combustion chambers, effective compression rises slightly. That increases knock sensitivity under acceleration. The driver doesn't see this on the dash, they just hear a slightly sharper engine tone under throttle. Carbon accumulation typically increases after extended short-trip driving or long oil intervals. Intake valve deposits and piston crown buildup affect airflow and combustion characteristics over tens of thousands of miles. Another contributor is minor exhaust leakage. A small crack or manifold bolt failure creates a sharper tone during acceleration. Under load, exhaust pressure increases, amplifying the sound. Many drivers mistake this for normal engine aging. Fuel delivery also plays a role. Injectors that begin to flow slightly unevenly don't immediately trigger misfire codes, but combustion smoothness decreases under load, subtly changing sound profile. The important part, engine acoustics change before measurable failure occurs. If your Ram sounds noticeably different during acceleration compared to 20,000 miles ago, that's a data point. Engines don't randomly change tone without a reason. You're either dealing with combustion timing changes, airflow restriction, or minor exhaust integrity issues. None of these start catastrophic. They begin as subtle acoustic differences under load, and most drivers tune them out instead of investigating why the engine no longer sounds the same. Change in sound is an early metric. Waiting until performance drops means you've passed the early stage. So there you have it, the early signs most Ram owners overlook until the repair bill forces their attention. None of these feel dramatic at first, and that's exactly why they get ignored. Pay attention to the small changes, because small mechanical shifts turn into big expenses over time. See you on the road, buddy.